presenting. Thanks so much for coming, tuning into this webinar. We're calling this one Innovations in Stormwater Filtration. And the idea is this is an opportunity to share some of the tips and tricks and lessons learned that we have come into as we've developed stormwater filter products for a variety of applications. Even though these sort of insights have resulted from our product development efforts, they are things that we thought could be useful for the general public. And so whether you're an engineer who is designing drainage systems, or you're a regulator who is trying to select the right products for their town, you might be able to learn something from these I don't know, insights that we've come across as well. Just a couple of little items about me. My name is Jeremy Fink. I lead the product development team at Hydro International. This is my contact information. Feel free to write it down. Contact me with any questions about this presentation. What I'm going to be doing here, I'm going to start off and just give a little bit of an overview about Hydro International for those of you who might not have worked with us in the past. And then talk a little bit about some of the regulatory drivers that have led us to pursue filters as a stormwater quality measure. How we at Hydro evaluate stormwater filter performance. And that's kind of a way of looking backwards at stormwater filter performance. So then we'll talk a little bit about how we use that information to predict what filter performance is going to look like in a new application or in a new geographic area. I'll talk a little bit about inspection and maintenance of stormwater filters. We at Hydro have our own maintenance department, and so we've gathered a lot of information about maintaining stormwater filters that has informed our new product development. We'll talk about how to troubleshoot a filter that maybe isn't performing optimally. And then finally, I'll give a little bit of an overview about a new product that we've put together called the Up-Flo filter with an extended maintenance cartridge. So I'll talk about that as well. About Hydro International, Hydro as a company is about 40 years old, and we're involved not only in stormwater management, but a whole bunch of other water management markets as well. And I won't read through this whole slide, but I think the important takeaway here is all of these markets that are listed here, whether they're wastewater markets or CSO markets or service and maintenance, they're all integrated. All the product development happens in the same place. And so we take lessons learned from one of these markets and are able to transfer them to other markets. So there's a lot of cross-pollination and cross-talk between these groups. So as you'll see as we get into this presentation, we've taken features from our CSO treatment products and from our hydrometry products and our service and maintenance divisions and applied them to stormwater filtration. Hydro is truly an international company. There are installations in 33 countries, offices around the world. I'm based out of this office in Portland, Maine. We have an office on the West Coast outside of Portland, Oregon. And the company headquarters is outside of Bristol, England, in the UK. But there are offices servicing all markets around the world. So to get into the topic at hand, stormwater treatment, you know, all of these pollutants here that you see listed are things that we're trying to get out of our stormwater runoff at one level or another. And depending on the level of treatment that somebody is targeting for their area, they're going to select a different technology. So whether you're talking about just very gross pollutant removal and you might just screen out trash or leaves and debris with a screen, that would be the very lowest uh, level of treatment. As you move into hydrodynamic separators, you start getting a little higher level of treatment. And then eventually you're finding yourself needing to get full filtration. And that's really what we're going to be talking about in this presentation, is sort of down at this end. Whether you're talking about a fully manufactured filter system, like this is what the Hydro makes, called the Up-Flo filter, or kind of a semi-manufactured filter system, like a tree in a box that comes off the shelf, but then would fit into a green infrastructure plan. Like for Hydro, this is a product that we make called the bioinfiltrator. All of these are forms of filters, and they all sort of follow the same rules that we'll be talking about here. Two terms that I'm going to be using in this presentation are municipal applications and industrial applications. And I wanted to define these a little more. At Hydro, we deal with both, and they inform one another. These circles are intersecting here because we take information and lessons learned from industrial and bring them to municipal and vice versa. So when I'm talking about a municipal application, what I'm really talking about is a filter application that is driven by development, usually in an MS4 community. So if you are in an MS4 city or town, and you are putting in a new parking lot or a new housing development or a new roadway, you are obligated to remove a certain amount of TSS. It's usually 80% TSS as dictated by the EPA. Now, as that has developed over time, what we've found is to get 80% TSS, we really need to start getting some fine material out of our runoff. And more people are requiring filter systems in order to get that 80% TSS removal. So this is municipal. It's really based on the certification of certain products or certain green infrastructure techniques in order to get 80% TSS. The other side of this is an industrial application. And an industrial application is a point source pollutant. So this is more like a scrapyard or a manufacturing facility or something, a food production facility, where the runoff from that site carries pollutants with it that need to be treated. These folks have a multi-sector general permit that applies to them, and they are mandated to have a certain level of water quality that comes off of their site, and they're checked on that. And if they don't meet that, they need to put in some sort of water treatment, often a filter. So you're going to hear me use these two terms kind of not interchangeably. They are in some ways apples and oranges, but in some ways very related. For example, when you're talking about municipal programs, which is usually certifying a piece of equipment or a green infrastructure technique, you are looking at the result of a certification from a program. And the two longest standing certification programs right now are run by the New Jersey DEP and the Washington Department of Ecology. Now, They both certify BMPs for use, and because they are such long-standing programs, a lot of other states look to them for reciprocity and say, well, if it's good enough for NJDEP or it's good enough for Washington Ecology, it's good enough for us. Just to give you an idea of what they're looking for, New Jersey DEP is looking for 80% removal of TSS, and the DOE is looking for the same, plus some other removals here. What's worth noting is they are talking about percent removal in all of these cases, which is usually the way municipal regulations are written. However, percent removal can be a tricky thing to evaluate. And I don't know how many people on this webinar have ever checked out the International Stormwater BMP database, but if you haven't, it's a great place to go to understand better what the performance of all BMPs, filters included, uh, can be. I don't know if you can see my citation here. It was put together by Right Water and Geosyntec, but they have a great FAQ document that says why do they not use percent removal as a measure of BMP performance? And I'll paraphrase here. They feel that percent removal is primarily a function of influent quality. So what they're saying is if you have a high influent concentration, you show that as a high percent removal. If you have a low influent concentration, you're never going to be able to show a good percent removal. And a lot of people need to keep that in mind when they're reviewing claims about percent removal. Somebody will say, oh, we removed 90%. Well, the question is, where did you start? Did you start with very high concentrations? If you did, 90% removal isn't that difficult to see. So when you're talking about percent removal, you need to ask a question: what was the influent concentration? Now, these guys who run the NJDEP and the Washington Department of Ecology, they're smart. They specified influent concentrations. So when they're talking about 80% removal or 50% removal, they know that they're getting what they want. So for the NJDEP, that's a lab-based protocol. The filters are tested in a controlled laboratory setting. They require a removal rate of 200. They require an influent concentration of 200 milligrams per liter. And that's like plus or minus 10%. It's got to be really spot on. And DOE gives some ranges for if you're, this is a field protocol. So you take your piece of equipment, your stormwater filter, you bring it out into the field and you test it. But whatever the influent concentrations are, they have to fall in this range, and as well as show these percent removals. Okay, so in some ways, that's just a way of getting to these effluent concentrations. If you know your influent concentrations and you know you're going to have these percent removals, then you're going to end up with effluent concentrations that are in this range. So ultimately, they're specifying an effluent concentration. They want TSS effluents in the range of 20 to 40 milligrams per liter, and these other pollutants as well. So what does the International Stormwater BMP database do? They skip the whole step of looking at percent removals, and they just go right to effluent concentrations. And we have, at Hydro, we've really tried to use the same approach as what was used in the International BMP database when we're evaluating filter technologies, because we agree with them that percent removal is just too squirrely a figure to toss around. It's too dependent on your influent concentration. So what they do is they use these kinds of plots that are called box whisker plots. And I don't know, again, how many people on this call have experience with this, but it's a great way to communicate a whole aggregate data set at once. So what I'm going to do here is I'm just going to zoom in on this first pair. This is looking at a bioretention system. So if we zoom in on this bioretention system, we can see this box and whisker plot. And I'll just explain quickly what we're looking at here. There's a table. This is a snips from that BMP database. There's a table here that shows, okay, this is summarizing 25 BMPs sampled. This blue one, this is the inlet, the influent concentrations. This green one here, this is the effluent concentrations. And this box represents 50% of the samples that they received. The whole whisker here, that's all the samples. These little circles up here, these are outliers, statistically determined to be outliers. And this, the waste on the bar here, that's the median. So that's a typical data point. And then this circle here, that's the average. So you can see the average has been drawn up by these outliers here. It's higher than the median. So it kind of gives you a sense of the skew of the data set. So this is such a great way of looking at everything and making some judgment calls, not based on a single, perhaps cherry-picked example, or even, you know, the oversimplification of, well, this is what happened to the averages, or this is what happens to the median, shows what happens to all the points in aggregate. And if you look at this, you say, okay, well, the influent concentrations, half of them ranged from 20 to 100 milligrams per liter. That's a little low compared to what the DOE would ask for, but half of the effluents were between, this is a log chart here, so between 5 and 20 milligrams per liter. So much lower than what was required by the DOE effluents. So, you know, this is, it gives you a sense that of what they're doing. So I'm going to come back to this later, because this is how Hydro evaluates these technologies as well. A quick digression here. As I mentioned, New Jersey DEP is a lab-based protocol, and Washington DOE is a field-based protocol. Which one is better? You know, they all have pros and cons. A lab-based certification, the nice thing about something that's done in the lab is it's repeatable. I can run a test on today, and I'm going to get the same results if I run it tomorrow. It's scalable. I can set up another laboratory somewhere else and expect that I'm going to get the same results in one laboratory that I'm going to get in the other laboratory. It's faster. I don't have to wait for it to rain. I just turn on the pumps and away I go. I'm wondering if I have a pointer here that's going to stay on. Oh, I do. Great. The what was I thinking? Oh, so some of the downsides, though, you know, when you have a lab test protocol, it's really an abstraction. You know, when you're designing the protocol, you're using your judgment to try to determine how to best mimic what's going on in real life, and that's always going to be making some assumptions that may or may not be true. So it's good for kind of maybe ranking and comparing apples to apples, but you need to keep in mind that it's just an abstraction. The other thing is that the lab-based protocols are really best used for TSS only. You can get lab standards for dissolved metals, or dissolved copper and zinc, or dissolved phosphorus, but those lab standards are so pure that they come out very easily. And in real life, the chemistry is complicated, and there's competing ion exchanges, and there's differences in pH and all kinds of things that make removals of metals and nutrients a lot harder than they are in the lab. So we only use this for TSS removal. For field studies, you actually have the actual chemistry of the site, which is great. and you can use that information to make some judgment calls. You have actual hydrographs. It's not just a pump being turned on and off. You have a rising leg as a storm starts, a falling leg, antecedent periods in between storms. All of these things play into the performance of a filter, and you don't get that kind of information in a lab test. Downsides, when you finish a field study, what you really know is about what's going to happen on that site on the year you studied. Every year is going to be different. Every site's going to be different. And to take that information and apply it generally is a little bit of a risk in itself. And then finally, often these tests are following a protocol in which you have certain tests, certain storms you can keep, certain storms you can throw out, the way you process the data. There's an abstraction there as well. So I'm gonna talk a little bit about how Hydro tries to combine the best of both of these in order to make some judgment calls about filtration. Okay. So industrial regulations skip all of that percent removal nonsense and go right to effluents. They say, for example, in the state of California, these are what have to come off your site. This is if you have an industrial general permit, right? So this is what has to come off your site. If you don't meet these, you need to treat your stormwater. Washington is even more stringent. So this is used for sites that are industrial sites or areas of environmental concern or something like that. So we pay very close attention to these because if we can meet these, we feel very confident that we can meet the municipal regulations as well. As a way of telling a story with a case study here, I'm going to keep going back and talking about a project that we worked on recently for a California transfer station. This is a spot where they take dumpsters like this and hose them out and get them ready to send the trash away. They came to us for some help with their stormwater. I'm going to be talking a lot about this site, but first I would like to try my best to send a poll your way, folks. Let me see if I can do this. I'm going to start a poll and I'm going to give a minute or so for you to give it an answer. Let's see. So you should see a poll here that is asking you what removal objectives you use. Let's give another 20 seconds here. All right, let's close this poll and see what we got. Oh, interesting. Okay. We share the results. See how that works. So you should be seeing some poll results right now. Looks like 65% of you use 80% minimum TSS removal to choose your technologies. 20% have a multi-sector or general permit to meet. So that's typical of what we see, I think, too. I'm gonna hide these results. See if I can start this presentation again here. Okay. So what we've done as an attempt to sort of bridge the gap between the lab testing and field testing is launch a column test program. And this program, we ask prospective clients to send us a bucket where, we provide the bucket. They fill it up with stormwater from their site, and they send it our way. And we put it through a column test and share the results. Now, this column test is designed to mimic what the performance would be of a full-scale filter unit. And so by doing this, we've created this kind of qualification program where if somebody comes to us with a challenge, we can know before we sell a piece of equipment what the odds are that we'll be able to treat it. A side result is we've been able to put together a very comprehensive database of um, filter performance results. So for example, these are results from column tests. We've got samples from all around the country that have been sent our way. These have gone through the column, but we don't stop there. We also put into this same database all of the samples that we've collected in the field from different applications that we've installed. This is an aggregate of all of the data that we have amassed. So in this case, we've got 48 data points, and you can see this whisker plot just like in the International BMP database. So I've got a red line here that represents what the California NAL level is. So you can see, some of them are below, some of them are above. Each one of these points represents a data point. This box represents half of the data points. That's sort of a typical median. I think this X right here, that's the average. So most people are actually, doing okay for their sediment removal. Some people come to us and say, hey, we are looking for a product to help with that. We're pretty comfortable with our filter getting down below 50 milligrams per liter with that TSS. And we have the same sort of data for copper removal, zinc removal. For you who like statistics, these are the p-values that show that these are statistically different data sets. So, we are actually seeing reductions from the influent to the effluent. That's something else that the folks at the BMP database do. But the other thing this lets us do is wisely choose what media we recommend in the application. The Up-Flo filter can be provided with either a granular media called CPZ, which is a blend of carbon, peat, and zeolite, and that's one kind of media we provide. And the other one is more of a membrane filter that is kind of a long ribbon that is suspended from the modules. And these are two different media types that we can provide. And what's great is we're able to use our test to compare those two media types. So for example, these are TSS removal results from the CPZ filter, the granular media, and this one is for the ribbon. And as you'll see further on through this presentation, even though we can get removals down below the NAL, the NAL stands for numerical action limit, the limit in California, there are times where we actually want to even reduce it even further. And the ribbon membrane media can do that. The trade-off is it requires a little more maintenance, so we try to use the CPZ when possible. So for our friends in California, they came to us with their qualifying sample, their bucket sample. We ran it through our column test, and you can see here the results for all the different chemicals, pollutants of concern. Now in this case, red means it's over the limit and black means it's under the limit. And so we were able to reduce the TSS as we expected, but we still had sort of high elevated aluminum and iron. Now, when we sent out these results to the lab, it came back that a lot of this aluminum and iron was in the particulate form. These metals can usually be separated into a dissolved fraction and a particulate fraction, and most of this was in the particulate form, which made us think that if we got this effluent concentration of TSS down lower, we would probably be able to reduce the aluminum and iron as well. So we did another test, another qualifying test, this time with the ribbon membrane filter media. And when we did this, we got the TSS effluent down to 6 milligrams per liter, and that was enough to lower the aluminum and iron down to the limits that were required. Actually, even though the influence were a little higher than they were the first time around. So you can see those reductions here. So we said, great, and we worked with this client to get a filter installed on their site with ribbon membranes. Now, about 6 months later, we went out and did an inspection. Inspection, as I mentioned before, Hydro has their own inspection and maintenance division. And so we maintain our own equipment, we maintain other people's equipment, we maintain green infrastructure. So we've got a wide base of knowledge for understanding what inspection and maintenance looks like. The message here is all filters need inspection. Whether you have a manufactured filter or something that is green infrastructure, you really need to be keeping an eye on it to get it to do what you want, either hydraulically or for removal performance. Now, in a municipal setting, usually those inspections are required by the permit. Whether they're actually carried out or not varies, but if you have an industrial permit, you really need to keep even a better eye on your maintenance, because you're going to be tested periodically. And these are 2 CPZ media filter bags. You really want to be running a test with clean media instead of running a test with dirty media and possibly getting bad results. If you're interested in finding out more about maintenance, our website has some great ebook references. This is one that was put together about maintenance, taking some of the lessons that we've learned from our maintenance division and getting them on paper. For example, this is just a piece from that ebook talking about what's involved with different kinds of maintenance, some price ranges, tools involved, a little bit of some lessons learned. So, all these kind of things are in guides like that, and really encourage you to pick up one of those ebooks from the website. So we went out to our friends at the California transfer station and did an inspection. And this is some of the photos from that inspection. You can see, what are we looking for here? Well, we're looking for buildup of sediment on the lids of the filter modules. And we're looking at water lines, some high water lines. So it looks like here's one high water line. So the unit hasn't been topping this blue bypass component very much, if at all. You can see the water line here. That's sort of the standing water line where the water stays at dry conditions. So we're looking at this and we're saying, okay, probably needs some maintenance. And then we popped the lid and we looked inside this blue outlet module here. What we saw inside the modules was this fine material starting to collect. And this is kind of a clay-like sludge material. We could see it inside those red modules as well. This is all after the filter though, right? So post filtration, this sediment is collecting. this can only be removed with maintenance. And we know from our laboratory tests that we've run that our filter ribbons filtered down to about 8 microns. So that allows clay-sized material to pass through. And and if enough of it passes through, and if enough of it settles out during low flow events, you're going to end up with some collecting downstream of the filters. Eventually, if you get enough built up, it will mobilize and start affecting your effluent filter, your effluent concentrations, your effluent pollutant concentrations. So another reason why to stay on top of maintenance is you want to keep that fine material from collecting downstream. If you're dealing with municipal filter applications, you probably are on a maintenance schedule like every 6 months or annually. If you are on an industrial permit, you need to take part in compliance testing, and that means quarterly sampling. Now, there are a couple of different ways you can fail your quarterly sampling. One is taking your annual average and exceeding from your annual average. And the other is if you have a high enough instantaneous maximum, that means on one day, you can fail that way too. Those exceedance results are in the public record. If you are in California and you go to their website, it's called SMART. All of the people with permits are there, and all of their effluent records are there. So alongside fines from the state that you're in exceedance, you're also open to citizen lawsuits from your neighbors or from the Conservation Law Foundation or these sorts of things. These regulations are increasingly ratcheting up to more stringent qualifications. There's new ones going into effect this year. So, it's this is what you're looking at when you're trying to maintain those general permits. So our friends in California did their exceedance, their quarterly sampling here, and sent the results to us and said, I don't know, Hydro, what do you make of this? Luckily, they took influent concentrations as well as effluent concentrations. And this is a lesson learned that I would recommend for anybody who's trying to evaluate their filter. You can take an effluent concentration and that gives you half the story. You should really take an influent concentration as well so you know what's going on. And these folks did that. So you can see here, copper was reduced from above the limit to below the limit. I've got influent concentrations here, effluent here, limit here. The zinc was reduced to near the limit. I think we had the limit's 260, we were 280, 260, so we are pretty close. Lead came in under the influent was under the limit, so that we didn't have to worry about. But same problem, TSS, aluminum, iron, still a little high. Coming in at 200 and we needed to be about 100. Once again, though, we saw that these were related. The aluminum and the iron were mostly particulates. So there's something going on with the TSS here that we didn't understand. This brings us to troubleshooting filters that are giving you a hard time. The Hydro provides an inspection checklist with all of our filters so that you can kind of run through these troubleshooting scenarios on your own. But these are the sorts of things you're looking at. If you have a high influent concentration, and like I recommended, take a look, some of this can be what's referred to as poor housekeeping. And it's a little bit of jargon, but if you can do some better street sweeping or better vacuuming, if that's possible, that takes a load off your filter equipment that is measurable. If your effluent is starting to look a lot like your influent, probably you're looking at some seals that are leaking. If your effluent is higher than your influent, then you're looking at something called breakthrough. And this is, if you think about what a filter is doing, it's essentially taking pollutants and concentrating them in a sequestered area, whether it's media or the surface of a membrane or something like this. It's concentrating and sequestering that pollutant. Eventually, that becomes saturated and starts exporting. And if that becomes the case, they call that breakthrough, and you need to change your media. If there's standing water in your system, that's a failure called occlusion, which is a fancy way of saying your media is clogged. The surface of the media has become blocked and needs to be changed out. A frequent bypass can also be a symptom of that. And then finally, occasional bypass can sometimes be a sign of changes in your runoff routing. Maybe you designed the system to receive water from a certain area and something has changed on the site and now it's getting more water than you saw before. That could cause some occasional bypass that you might need to deal with. So our friends in California, we took a look at their influent and effluent concentrations and tried to read the tea leaves a little bit and see what might be going on. This is what we saw when we compared. Luckily, we had done the qualifying run with the column test, the bucket test. This blue and purple line here, that was their qualifying test. So we went from 200 down to 6 milligrams per liter, if you remember. These new, the jar sample that they took at their quarterly started at 500 milligrams per liter, got down to about 200, a little over 200. So this made us feel good in the sense that the filter is still removing TSS. It's removing it at a rate that is kind of comparable to what we saw in the qualifying tests, but the influent concentration is higher than we might have expected. Maybe something that we can fix with some housekeeping. Also, we could probably get this a little lower if we had fresh media and a maintained unit. So this made us feel like with maintenance, we were in the ballpark. Here's the corresponding iron results, same story, which makes sense because so much of the iron is particulate. The other thing we did when we were doing our inspection is we installed data loggers. These were level sensors that we put in that are attached to a cell signal. They report out once a day with what the water levels were instantaneously in the unit. I think they take measurements every minute or something like this. It's pretty fine resolution. This one happens to be manufactured by Hydro, but you can get them manufactured by lots of different people. But this can be really valuable in troubleshooting a filter that you're not sure is working. So for example, this is the report that we got out from our level sensor. And the first thing we looked at kind of interpreting this report was, well, is the system going into bypass all the time? We know this is the water level that would represent bypass. And no, the system's not going into bypass that often. It went into bypass twice, maybe 3 times, so on some big storms. So that looks okay. The second thing we looked at was, well, was it in bypass on the day that we took our compliance sample? This is the day we took the compliance sample. It was not in bypass that day. So it was operating all right. That seems like that, so that kind of rules out occlusion as a problem. This part here was curious to us though. This is dry weather conditions from the beginning of October to the beginning of December. There were no storms. And I actually had to go back and check our historic weather to make sure that that was right. That seemed strange, but it was. There was no rain in this part of California during that time. But still, there were spikes every day, a little bit of water introduced into the system. So this indicated to us that probably some process water from the site was being washed into the filter. And that makes sense. We know that this is an area where dumpsters are being washed out, and that water probably is just being hosed right into the storm drains. Um, is that a good idea? Well, it's ultimately a decision for the for the transfer station, but it might require additional maintenance for them. So here's, this is where our recommendations were, along with doing a full course of maintenance on the filter and setting up some quarterly inspections and a regular maintenance program. They may want to look at redirecting that operational wash water to a sanitary sewer, or plan on doing more frequent maintenance on their stormwater system. But without that level sensor installed, it would be very difficult to know that that runoff was finding its way to the filter on a daily basis. It's time for poll number 2, folks. What kind of preference would you give to a treatment system that had some real world performance data demonstrating its efficacy? We'll give it another 20 seconds or so. All right, let's see what the results are. Looks like the majority of you agree that real world data is a good approach for evaluating a filter. I think Hydro agrees with you there. So when we looked at that troubleshooting chart here, when it was clear to us that most of the problems that happen in a filter come from media exhaustion, media clogging, media breakthrough, things that could be stopped if maintenance cycles were extended. The more sediment that is collected in the system, the better and more reliable the system is going to be. So we thought, well, how can we extend those maintenance cycles to capture more pollutants? And this is where our this is where our cross pollination between departments really came in handy. This is actually a product from our CSO treatment catalog. And we have this product that has screens. These are conical screens that are backwashed with non-powered, gravity-fed, no moving parts way, where there's a backflush that cleans those screens periodically during a storm. And we thought, well, maybe we can do the same thing with our filter system. And so that's what we've done. And now we have 3 different iterations of the Up-Flo filter. We still provide the CPZ granular system, and we still provide the ribbon membrane system. But we have a third system here where we've taken our ribbon membranes and installed them in a housing that has a power-free, no moving parts backflush process that washes the pollutants that have been collected on the surface of the filter off in between storms. Now I've got a video here. Let's see if I can make it work. Hopefully this will show for you folks. But this gives a little bit of a sense of how this cartridge works. As the water level rises, it fills a reservoir at the top that is that holds some treated water. So now you've got water that's coming up through these filters, going into this treated water reservoir, and then exits the system. At the end of a storm, that treated water drops back through the ribbons, rinsing them clean, essentially. So that probably went pretty quickly. Where this is a very new product for us. We're just getting out some of our promotional material now. If you're interested in this, let us know in the survey at the end of this presentation, and we'll make sure we get you the most up-to-date description of how things work and understanding of the ins and outs of this product. But the real takeaway for this is how do we know that this can treat more sediment, more pollutants in between maintenance cycles? And there's a lot of different ways that you can evaluate this. But here's one way that you can do yourself, using numbers that are publicly available. I took these numbers from our new Up-Flo filter with the extended maintenance cartridge was recently approved by the NJCAT program, which is the certification arm of or the verification arm of the NJDEP certification program. So these numbers are all available on the NJCAT website. But if you take our Up-Flo filter cartridges and compare them to the leading stormwater filter cartridge, like if you just compare the cartridges with the 27-inch drop, let's say, the first thing to notice is our cartridges are much smaller. We designed these cartridges to be 12-inch squares, 1 foot square, so that they could be packed very economically into a filter vault. By comparison, the leading filter uses a 20-inch diameter round cartridge that can't be packed in quite so economically. Get my pointer here again. So even though the filter cartridge is smaller, they capture just about the same amount of sediment, 51, 55 pounds. Now, because you can pack them in tighter, the Up-Flo filter uses only 1.7 square feet of vault area per cartridge, while the leading filter uses 3 square feet of vault area per cartridge. And as a result, if you look at how much sediment can be captured per square foot of vault, the Up-Flo filter actually can capture 65% more sediment per square foot of the vault area. 30 pounds versus 18 pounds per square foot of vault for the same flow capacity. So that's one way to look at this. If you want to get a sense of how this could work for projects you're evaluating, you can contact a local sales manager, and they'll be happy to explain it to you. So a few conclusions. That's the end of this presentation. Lessons that we've learned from the industrial filter applications can be applied to those municipal filter applications and give us some confidence that the systems are working the way people intend them to. When you're talking about percent removal, be sure you ask what were the influent concentrations to start, because that's the key to understanding what percent removal means. If you're evaluating a filter, ask, are these lab results, are these field results, and treat those appropriately, knowing that lab results are really only good for TSS removal, not for removal of metals or nutrients. You need field test data. Try to use aggregated data if you can. If somebody gives you one data point from one site or from one test, that's, you know, that's great, but you really want to evaluate everything as an aggregate. All filter systems, whether they are manufactured, semi-manufactured, or green infrastructure, need inspection and maintenance to keep working properly. Remote monitoring systems, if you can get them specified, go a long way to making sure that the systems are running properly. And that's it. There's going to be a post-webinar survey headed your way. You can use that. If you fill out that survey, you'll be in the running for a $50 gift card. The winners will be notified this week. We'll send PDH certificates out no later than tomorrow. So thank you everybody for attending the webinar. Really appreciate it. And if you have any questions, again, my name is Jeremy Fink. You can contact me. Actually, let me skip back up to my contact information again. But thank you very much. I'll leave this with my contact information on the screen, and I appreciate you attending.